today we start with the next unit. Actually, for our test 3, we have 2 units. The last 2 units, Unit 4 and Unit 5. Okay. In Unit 4, up to whatever we have seen, up to the impulse and momentum, impact of elastic bodies. So after that, we'll have test 3, and the other unit, Unit 4, Unit 5, we will cover up to friction. Okay, friction of surfaces. Friction of surfaces. So the vibration part and the rigid body dynamics in Unit 5, these 2 parts we will cover later. Okay. So we start with Unit 5 now. So the Unit 5 syllabus, it goes like this. The first chapter is about the frictional force, friction between the surfaces. Then the second chapter will be translation, rotation of rigid bodies. Okay. In Unit 4, we have covered dynamics of particles. Dynamics of particles, which are started with Newton's second law of motion, the application of Newton's second law of motion for finding out the parameters of motion like velocity, time, etc. Okay. And the energy principle, work energy principle, impulse momentum principle, and also impact. Okay. In Unit 5, we start with friction. So what is friction? How will you define friction? Resistance to motion. The force, resisting force against motion is called friction. Why friction occurs? Rough surfaces. The surfaces are not smooth. Okay, it is the property of the surface. It is not the property of motion, it is not the property of external force, it is the property of the body or surface, we generally say. Okay. So friction is defined as the force of resistance acting on a body which prevents or retards slipping of the body related to another body. So it prevents slipping, okay, or it prevents slipping of the body over the other body. So there is a resistance provided for the motion of the body, so that is called as friction. So how the friction occurs? It is due to the rough surfaces, which occurs due to the microscopic interaction between the surfaces. If the surfaces are not smooth, there are projections. Rough surfaces, what do you mean by rough here? There are projections. The surfaces are not flat, there are projections. So these projections interact with each other in the microscopic level, very minute microscopic level. These interactions produce friction, resistance for motion. Like this, we have 2 bodies, okay, the one block and a plane. At the surface, the body is trying to move. If you see at the microscopic level, there are rough interface. So these rough surfaces, they interact and resist the motion. So friction results in the force in the direction opposite to the motion. So the frictional force will be always acting in the direction opposite to motion. Because friction is a resistance to motion, so it will resist the motion. So motion will occur in one direction, means the friction will be occurring in the opposite direction. Okay. Is it a cone or band? Huh? Both. So where we need friction?
Braking.
Brake. Walking. And walking. Okay. Then any other example apart from brake?
Sir, producing a motion, sir.
Producing motion.
Well, producing heat, sir.
Producing heat.
In the matchbox.
Matchbox. Okay, good. Then
The back wheels act as a
back wheels.
back wheels and the friction along the easier.
Frictional road resistance. Actually, there should be some friction. Frictional contact between the wheels and road. Okay. If the road is very smooth, then it is difficult to move for the vehicle. Okay. There will be a slip. Okay. There is a slip. Okay. Friction? Yeah. shaving. எனக்கு ஷேவிங் பிடிக்காதுன்னு தான் சொல்லக்கூடாது. So we have, what is this? Brake. Okay, the brake in the bicycle. The brake shoes are in contact with the wheels. So this is a good. Okay, this is necessary, need. Whereas, what is this? Shaft in a bearing. Okay, this we call journal bearing. There is a small gap existing between the shaft and the bearing surface. The small gap will be filled by a thin film of lubricating oil. So this kind of lubrication we call it as journal bearing. Okay, hydrodynamic lubrication. Hydrodynamic. As the shaft rotates, okay, there is a gap. This gap will suck the oil, so it will be dynamic in nature. The lubrication is called hydrodynamic lubrication. Hydro refers to oil. Okay, some fluid is there, some liquid is there. So this liquid is being active, so we call it as hydrodynamic lubrication. For example, in the crankshaft and all, we have such a kind of lubrication, hydrodynamic lubrication. Okay, so this journal bearing is where we have to avoid friction. In order to avoid friction, some lubricating oil is provided. Okay, so this is where we need to introduce the friction. This is where we need to avoid friction. Okay, there are two situations. This is the classification of friction. You can classify friction as dry and wet friction. Okay, dry and fluid friction. Our syllabus is covering only the dry friction. So under dry friction, we will see the static, kinetic, and the angle of friction. These are some of the parameters which we are going to study under dry friction. Dry friction is otherwise called as Coulomb friction. Okay, Coulomb friction. And where we apply friction, like wedges, if the two wedges are in contact, like camshaft is a lobe. Okay, there is a wedge, so it pushes the rod. Okay, follower may be knife, it will be a wedge. Similarly, journal bearing and thrust bearings, screw and nut, bolt and nuts, they are also working on friction principle. Then we have a clutch, automobile clutch is there, it also works on the friction principle. So where we apply friction, we introduce friction. What is the difference between the brake and the clutch? Are they same? What is the similarity and what is the difference? The brake and clutch.
Both are used for engaging in discipline.
Okay, that is the similarity. What is the difference?
Brakes are applied for friction, but clutch is to remove that friction. Stop flying. Clutch reduces the frictional force and brake increases the oxygen.
No, both need increased friction. Okay, both need high friction. If friction is less, brake will not work properly. There will be a slip. If friction is less, clutch will not work properly. Both should have good friction. There is no increase in friction or reducing friction. By applying brake, we increase the friction, of course. Okay. So what is the difference? Performance-wise, I am not asking about the construction or location. Okay, function you know, it is to stop the vehicle. Brake is to stop the vehicle, whereas clutch to change the gear, to change the speed of the vehicle. Okay, so here itself we have the hint. It stops the vehicle, whereas it manipulates the speed. How it manipulates the speed? Changes the speed. That's what. How? Actually, if you want to stop the vehicle, you have to connect a rotating member with a stationary member. Both are having two bodies. Okay. In brake, we have a rotating body and a stationary body. If you apply the brake, the rotating body is connected with the stationary body. So it will also become it will also become no motion. Here, come to rest. It will also come to rest, like a stationary body. Whereas in clutch, both are rotating body. One rotating body is connected to another rotating body. For example, the flywheel, from where we take the motion, is passed on to the gears. Our rear wheels are connected to the gear transmission mechanism. So this is engaged and disengaged. So the two rotating bodies are connected. Two rotating bodies are engaged in case of clutch, whereas in the case of brake, one rotating body and a stationary body are engaged or disengaged. Okay. So this is the difference. So we have a clutch also where we have to introduce friction. Okay. Now we will see in detail about the drive friction or Coulomb friction. Okay. Drive friction is otherwise called as Coulomb friction. Suppose you consider a block W is resting on a plane. So the weight of the block is W. So we have only a reaction due to the weight. Normal reaction N acting in the direction opposite to the weight at the contact surface. Okay. Suppose if you apply a horizontal force P, the horizontal force P is applied to move the block. So when you try to move the block will not move immediately. Okay, there will be a resistance provided. So this resistance is called friction. The small horizontal force if you apply, it will remain stationary up to some point due to equilibrium. So if you apply a force in the horizontal direction, if it is to be remain stationary, if it is to be in equilibrium, there should be an opposing force. The opposing force is called static friction force. Okay, so this applied force is P, friction force is F. Okay, so both are in equilibrium, so that there is no motion. If you further increase, so these two are proportional. If you increase the force, horizontal force, the friction also get increased up to some limit. So these two are proportional. Okay. As P increases, the frictional force F also increases until it reaches a maximum value Fm. So the proportionality between the applied force and your friction force is there. So this is how we get. If you draw a diagram, this F and P will be proportional. So you will get a linear curve like this. After reaching this Fm maximum value of friction force, so this proportionality is given by mu. Okay. Actually your force, friction force is proportional to normal reaction. So we call it as F equals to mu times N. This mu is called static friction, coefficient of static friction. Okay, mu S. Mu S refers to coefficient of static friction. So if you further increase, the block will move. Okay, if you further increase the horizontal force, now friction force becomes less. But there is a friction force, but it becomes less. It will again give some resistance, but P is more than Fm, so the block will be moving. Okay. So the friction now we get is called kinetic friction. Earlier, the block is in equilibrium due to static friction. Now the block moves, still there is a friction. So this friction is called kinetic friction. So the kinetic friction can also be given as equals to mu K times N. Mu K is coefficient of kinetic friction times N. So we will get motion like this. There is no motion. After reaching, the friction becomes less than the applied force, but the motion begins here. Motion begins here and motion goes. Okay? So there are two frictions, static friction and dynamic friction. Static friction exists when the block is at rest, at equilibrium. The applied force is not enough to overcome the friction force. Okay. So the force, frictional force is given by mu times the normal reaction. Mu times the normal reaction. Always F equals to mu N. Mu can be mu S or mu K. It can be coefficient of static friction or it can be coefficient of dynamic friction, kinetic friction. Okay, static or kinetic friction. And these coefficients mu S and mu K, as I told earlier, is not depend on the force or area of contact. It depends on the nature of the surface. Whether how much rough is it or what kind of material is it. It can be a material property or it can be the surface property. Okay. So surfaces, nature of the surfaces. So mu S and mu K. mu. The coefficient of friction, mu s and mu k, it depends on the surfaces. Okay, what material we use and how is the surface. The two surface here refers to the material. Between wood and wood, it will be different. Okay, metal and wood different. Metal and non-metal, it will be different. So these are some of the coefficient of friction between the different materials. Metal on metal, metal on wood, metal on stone. Okay, so it depends on the type of material we use and also the surface. Generally, we consider, it's in microscopic level, so we consider it is rough. All the materials are not perfectly smooth. Okay, so they are rough and there is a friction. So the coefficient of friction should be so high in a packaging system, transfer line, conveyor line, so that when the package is moving, the package should not slip. If it slips, it cannot be transferred. Okay, this is one of the applications where the static friction is necessary. The coefficient of static friction should be so good so that the packages will not slip. There may be four situations in our friction. Okay, you have a weight W which has another additional force P. There is no horizontal force. No horizontal force, so no motion. No motion, no frictional force also. Okay, so the total downward force is resisted by normal reaction N. So N will be equals to P plus W. N will be equals to P plus. This is one condition where no friction, no horizontal force, no motion, no friction. Okay. This is also the condition where no motion, but here there is a horizontal force. Consider force P, it will have two components, vertical and horizontal component. The horizontal components will try to move the block, but it will be resisted by friction. So as it tries to move the block, there is a resistance provided by the friction. This F equals to mu s times N, but still no motion. This horizontal component is less than the maximum frictional force. Horizontal component is less than maximum frictional force, so no motion. Here, both are equal. The horizontal component is equivalent to maximum frictional force, so motion begins. Impending refers to beginning of the motion. Okay, generally we use the word motion impending. Motion starts, motion begins here. Okay, so here the Fs, your Fm maximum frictional force will be equal to the horizontal force which is applied to move the block. Here it is less, frictional force is less than Px, so motion exists, motion occurs. So there are two situations. In the first one, no motion and no friction. Second case, no motion because more friction. Friction is more than the horizontal component. Third case, the frictional force is equivalent to the applied force, so the motion starts, it tends to move. Then fourth case, the friction is less than the applied force, so motion occurs. And if you consider problem point of exam point, we may have three situations. We are given static friction, coefficient of static friction, applied forces. We have to see whether the body will be in rest or not, whether it will be in equilibrium or not. Or we may get a problem like this. All the applied forces are known. Motion begins. We have to find out. So if they say motion begins, it's still not moving. It tried to move. Okay. So at that point, you will have only static friction. So we have to find out coefficient of static friction. If they say motion begins means it just tend to move. Okay. So still it is in static condition. Fm, it reaches maximum value. The applied force is equivalent to the maximum friction force. Then here it may be a condition motion is impending, we have to find out the magnitude of the frictional force. So you have to find out whether it is in equilibrium, or you may have to find out the coefficient of friction, or you may have to find out the frictional force or any unknown force. Okay. So these are the three situations where you get the problem. And there is one more component, angle of friction. Okay, suppose if you have the force system, consider W normal reaction applied force. Okay, we replace the applied force Px will have a horizontal component. It will tend to move the block like this. The normal reaction N. So we replace the normal force. We have two components acting against the system. You have a block. The weight of the block is acting downwards. So there is a reaction. Okay, normal reaction N. Similarly, you have the force P, which is resisted by. So these two are reaction forces. Your N and F are reaction. Okay, P and N are action forces. P is the applied force. We try to move the block, and W is the weight of the block. Okay, these are the known applied forces. For these two forces, it is better to replace all the reaction forces N and F, two reaction forces, by the resultant force R. We replace it, we combine the two forces, get the resultant. While showing the free body diagram, we replace the two forces, frictional force and normal reaction force, by a resultant force. Okay. In the first situation, where there is no horizontal force, your normal force will be equal to the resultant force. Okay. In the second situation, you have an applied force acting in the inclined position. So you have Px and Py. So there is a normal force and there will be also a frictional force. We replace the two forces by the resultant R. So the angle made by the resultant R with the normal is called theta, angle of friction. Okay, the angle made by the resultant R, resultant of the two forces, normal and friction. Resultant R with the normal's direction is known as angle of friction. Okay, so in the first case, theta is 0, phi is 0, here phi is existing. Okay, here you have phi. And as the motion impedes, what will happen? When the F reaches maximum value, friction force reaches maximum value, as the block tend to move, your theta, your phi, angle of friction will become phi s equivalent to static friction. Phi equals to phi s, maximum value. And as the block starts moving, this phi s will become phi k, angle of kinetic friction. So then the angle can be given by Fm by N. You consider the right angle triangle. R is the hypotenuse. N and F are adjacent opposite sides. So you can find out tan phi equals to Fm by N. Fm by N. Or we can say Fm is replaced by mu times N. We can say tan phi s equals to mu. Tan phi s equals to mu. Or the tan of angle of static friction equals to corresponding coefficient of friction. Tan of angle of friction equals to corresponding coefficient of friction. So this is known as angle of friction. Tan phi equals to mu. And there is another angle called angle of repose. Angle of repose. Say you have a body resisting on an inclined surface. It is now the theta is 0. Suppose if you have a small inclination, okay, so the block will remain stationary. We have a small inclination given theta. So the block, if you want the block to remain stationary, what should be the maximum angle? Maximum angle needed to keep the block in position. If the block is further tilted, the block will start moving. If the inclination is further tilted, the block will start moving. So this angle theta is called angle of repose. here if you see, if you draw the free body diagram, consider the forces, this theta will also be equal to phi. Theta will also be equal to phi. So normal force, W cos theta, tangential component if you want to draw, this is W sin theta, this theta, you can tan theta equals to mu again, tan theta equals to F by n, or we can replace F by mu n, so finally we get tan theta equals to mu, that is equals to tan phi. So we can say theta and phi are same, angle of repose equals to angle of friction. So if you increase the angle further, you get the situation like this. So your theta equals to phi. Okay. So this theta is called angle of repose. Angle of repose. So you have two angles, angle of friction and angle of repose. Okay. Angle of repose will get into existence when you have an inclined plane. Inclined plane. The plane is inclined and the block, some body is there. So what should be the maximum angle you can tilt that can be found by considering angle of repose or angle of friction. We'll solve our problem so that you can understand how it comes into. This is a simple problem now. We start with this problem. You have a block, 75 kg mass. Mass of the block is 75 kg and an inclined force of 300 Newton is applied at an angle of 30 degrees. We have to find out the coefficient of static friction. Coefficient of static friction. So how will you find out? First we resolve P into two components, horizontal and vertical components. Write the equation of equilibrium. We will go to that our previous theory we obtained by equation of equilibrium. So we have the block. If you consider the block, free body diagram of the block, normal force, then W, then this P, 300 Newton, we resolve it into two components. This is theta given as 30 degrees. So what would be this? Px, this is Py. So what is Px now? What is Px?
Cos 30.
Simply cos 30.
300 cos 30.
300 cos 30 Px. And Py, the last guy. Mr. Last arrow. What is Py? What is the value of Py? Nina, what is the value of Py? So what we are doing in the class? Sign? No. This side last. What is the value of Py? 300? 300 sin 30. Is it correct? Now we resolve the forces horizontally. Okay. So we consider the horizontal forces. So in direction like this. Say this direction positive. Rightward positive I take. So you have 300. One more force is missing. What is that? Main force is missing. Frictional force is missing. So 300 cos 30 minus F. Actually, we assume, the motion is, we assume that Px is acting in this direction, so the block will tend to move in this direction, so friction will be in the opposite, we assume, But we can find out whether our assumption is correct or not after getting the final value only. So here F will be 300 as that. So this is your F. Similarly, find out the normal. So to find the normal, say I have assumed all the downward forces positive. Okay. W plus 300 sin 30 minus n equals to 0. Okay. W is the weight and Py, the vertical component of P acting downward. So downward is positive. I have considered downward motion as positive. Minus n. Minus n. N is acting upward. So downward positive. So n is upward. So I took it as. So W is 75 into 9.81. Okay. The mass is given into 9.8 will be the Newton. Plus 300 sin 30 equals to n. Equals to n. Okay, so we got force as well as the frictional force as well as normal reaction. After obtaining these two, we can find out mu. Mu is 0.29. Okay. Any doubt? We will see the next problem. Okay? Saddam Hussein. Moment, sir. First equilibrium diagram. Force equilibrium. So we have another problem. In the inclined plane. Now the block is in the inclined plane. Okay. A 450 Newton force acts on the block which is placed on an inclined plane. The weight of the block is given 1350. 1350 Newton is the weight of the block. Siddha, Yarama? So don't duck. So we have a block which weighs 1350 Newton. A force of 450 Newton is applied. Inclination of the block is given. You are asked to find out whether the block is in the equilibrium or not. Okay. And also the maximum frictional force. Value of the frictional force. If it is in equilibrium, it's not equal to 0. The applied force will be equal to the frictional force.
Sir, wait, sir.
Weight is 1350. 1350 Newton. Okay. You draw the free body diagram of the block. Follow the same procedure. Find out the normal force. Find out the frictional force. Weight will act like this, W. friction will be acting like this. Okay, you have to resolve all the forces parallel and perpendicular to the inclination. Okay, you can resolve all the forces. So to resolve W, you have, are you listening? So we have P, the applied force 450 Newton, friction force developed, and also the normal reaction N. Okay, so the W is in this angle, so this angle will be same as this angle. Okay, these two angles are similar. So we have 5, 3 and 4, same fraction. Okay, so we have to resolve all the forces parallel and perpendicular to the inclined plane. Consider, say, like this. So this is X, this is Y. Parallel and perpendicular to the inclination. Or you can do vice versa. You can resolve the forces parallel to X and Y also. This W is, so we can, so here many forces are inclined, so it's better we resolve it parallel to the inclination. Only W is to be resolved. Okay, if you consider the other way, if you resolve all the forces parallel to this X and Y, you have to resolve this into two. You have to resolve this also into two components. So it will become tedious. In order to avoid that, you make your X and Y parallel to the inclined plane. Resolve all the forces parallel to and perpendicular to the inclined plane. Okay, so that is how it will become simpler. So if you resolve parallel to X as shown, yeah, say this direction, rightward positive, 450 minus W. If you resolve, it will come like this. W is 3 by 5. I write it here. W into 3 by 5. Okay. W into 3. Sine means opposite side. Sine, you say this 3 by hypotenuse. 3 by hypotenuse will give you opposite side. Okay. Yeah, we resolve it like this, parallel to the inclined plane. Then minus F equals 0. Okay. From which you can find out F. Find out F. W is given 41350. Similarly, resolve Fy parallel to Y. This direction positive, upward positive, for example. N minus W 4 by 5. Only two forces, N minus W4. So you can find out N. You can find out F from the first equation, N from the second equation. F and N are found. Okay, step 1. We have to find out the value of the frictional force and normal reaction, and we have to check whether they are in equilibrium. Right, I will finish the problem, then I will complete. Okay, so first we find out F and N. So F we got minus 360 Newton. That means your assumed direction is wrong. So the frictional force acts in the upward direction. Frictional force acting in the direction same as the applied force. Because the block moves up, minus 360 Newton. This is 450 Newton. Frictional force is 360 only. So the magnitude is less than the applied force. So the block will be automatically moving up. Okay. So as it moves up, the frictional force like this. Now we have to find out the maximum frictional force considering your mu. You are given mu as 0.25. Okay. So maximum frictional force will be mu into N. Mu into N. Static friction. Okay. Mu into N. So it's 270 Newton. Actually, the force required to keep the equilibrium is 360 Newton, but the maximum force is 270 Newton only. So there is no equilibrium. Equilibrium cannot be obtained. Actual frictional force, considering the coefficient of friction, is 270 only. It is given mu as 0.25. Considering the coefficient of friction, the frictional force we can have, maximum frictional force we can have is 270 Newton only. Whereas from the previous slide we have found the equilibrium force is 360. Okay, so this is 270. So the block is not in equilibrium. Okay. The magnitude of actual friction force you can obtain. So it moves. It moves means it is kinetic now. Find out the kinetic friction force. Okay. Yeah. Actual friction of mu is there. W sin theta was 3/5. Sin theta வந்து opposite side पे hypotenuse. W sin theta தான அது மட்டும் போய் ஆன்சர் தப்பு. ஆன்சர் தப்பு. Actually, this block is not in rest, not in equilibrium. It moves. So, kinetic actual. As a maximum finish. Problem. You have two blocks, block A and B, crate A and B, connected by a string. So two crates, the weight of the crates are given. Allow the So the weight of the crate 150 Newton are given. They are tied together by a rope. The rope is parallel to the inclined plane. Coefficient of friction between crate A and the plane, crate B and the plane are given 0.2 and 0.5. We have to find out this theta and also the tension. We have to find out theta and tension. Tension between the tension existing in the rope CD. Okay. So first you consider block A. Draw the free body diagram for block A. Then free body diagram for block B. Sigma Fy. So we have three unknowns. We don't know what is the frictional force. We know only W. We don't know F. We don't know N and also theta. Three unknowns are there. Okay. So sigma Fy, sigma Fx equation you can use for solving. Then one more thing, friction. So four forces are there. Normal will be if the block trying to move down. Okay. So it will be resisted by the normal reaction, like support reaction. Normal force is a reaction force. Okay. So the weight of the block or total block is moving down. It is resisted by the plane. Resisted by the plane. So it will be acting. So friction force, tension, W and N. Okay. So resolve the forces parallel perpendicular to the plane. Resolve because you have three forces parallel to the plane or perpendicular to the plane. Only W is not parallel or perpendicular to the plane. So it is easy to resolve them parallel and perpendicular to the plane. You consider this as X and perpendicular as Y. Okay. So find out sigma Fx. Or sigma Fy also you can do. Only one horizontal force is there. So for block A, only one horizontal force is there. You consider sigma Fy. Okay. So the angle we don't know. At present, this is theta. Since this is theta, okay, the angle made by the inclined surface and horizontal is theta. So angle made by the normal and W will also be theta. Okay. So this will be your cos W sin theta. This is W cos theta. W sin theta and W cos theta. Okay, these two components. W is resolved into two components. So sigma Fy, if you consider, say upward positive I have taken. So W, everything is minus N, okay. N minus W cos theta. Then okay, only two forces, N and W. So this is for block A. grade A. If you consider grade B, so if you want to find out Fx,
a double centimeter,
minus F. Okay?
sir, the friction appearance, the friction is
Yeah, so if you run wrong, it will get negative. So block will move down, friction will move up actually. I have drawn like this, so I take it section. So T minus, okay? Then for block B, you can replace W, you can replace by 100, okay? This W1 we can have.
sir, you will minus T on sir, grade B.
Yeah. This directly was.
Grade B commercial.
Okay? So find out sigma Fy again. First, find out N and F. First,